What is the world made of? How many different materials are there? There's no definite answer to this question. Every day new materials are being made. In fact, you might have made some new materials yourself if you've ever experimented in the kitchen. Here's a new material that never existed before, and probably never will again. We use many new materials every day. Stainless steel is a new material. So are the hundreds of plastics we use today. But how can we keep making new materials? Isn't there a limit? Let's ask another question. Is there a limit to the number of words we can use? You know that there isn't, since we're always adding new words to our language. Yet all the words in the dictionary are made up of something much simpler, the letters of the alphabet. These letters are the building blocks from which all our words are made. This is a chart of the building blocks from which all materials are made. These building blocks are called atoms. Each atom has a name and also a symbol. There are more than 100 different atoms. From them, all the materials we know are made. The symbol O stands for oxygen. This chart has other information, too, for chemists to use. C stands for carbon. H stands for hydrogen. Al stands for aluminum. Fe stands for the Latin name for iron. Some of the symbols are not like the names we commonly use, but it doesn't take long to learn these symbols. Atoms are so small that a single drop of water contains billions upon billions of them. They are so small that no one has ever seen them, even with the most powerful microscopes. With such microscopes, we have been able to photograph unusually large groups of atoms. But the separate atoms which make up these groups are far too small to be seen. But by observing how materials behave, we have learned how atoms behave, and we have made models of atoms to help us learn more about them. Atoms are almost never found separately in nature. They combine with other atoms, according to natural laws which chemists know. These combinations are called molecules. Every material is made of its own kinds of molecules. There are water molecules, salt molecules, sugar molecules, molecules that form cotton, molecules that form plastic dishes. Each different molecule is made up of different combinations of atoms. This model represents a molecule of sugar. Molecules may contain many atoms, but they're still very small. If every molecule in one grain of sand suddenly became as big as the grain itself, we would have a cube a mile high, a mile wide, and a mile deep. Here we have combined models of 3 atoms into a molecule that consists of 2 atoms of hydrogen and 1 atom of oxygen. Chemists write this formula H2O. Yes, this is the formula for water. A drop of water contains billions of molecules, each with 2 hydrogen atoms and 1 oxygen atom. Both of these liquids look like water, but this is not water. It acts quite differently, as you will see when we pour a solution of iron in each liquid. This is hydrogen peroxide. Its formula is H2O2. Each molecule contains 2 atoms of hydrogen and 2 of oxygen. That is 1 more oxygen atom than a molecule of water. So you see that 1 atom more or less in a molecule may result in a great change in the nature of the material. By using electricity, we can separate water into the 2 gases which form each molecule of water: hydrogen and oxygen. Since each molecule of the gases contains 2 atoms, the chemical symbols are H2 and O2. But hydrogen cannot ordinarily be separated into other materials. Neither can oxygen. For this reason, hydrogen and oxygen are called elements. The molecules of elements contain only 1 kind of atom. Therefore, there are as many different elements as there are different kinds of atoms. Aluminum is an element since it contains only 1 kind of atom. Iron is an element. So is copper. Other elements include platinum and lead. Some elements, like carbon, come in different forms. A few elements, like mercury, are usually seen as liquids. A number of elements, like oxygen, hydrogen, and nitrogen, are usually found as gases and must be kept in containers. But most materials are made of more than 1 kind of atom. We find that ordinary table sugar, when heated, will separate into other materials. The white sugar turns black and gives off a vapor. You can see this vapor condensing at the top of the tube. These are drops of water, or H2O. The material left in the bottom of the tube is carbon. So sugar is not an element, since it can be broken down into hydrogen, oxygen, and carbon. We have already seen that water can be separated into hydrogen and oxygen. So water is not an element. Materials whose molecules are made up of more than 1 kind of atom are called compounds. Water is a compound, since each molecule contains atoms of hydrogen and oxygen. Sugar is a compound of hydrogen, oxygen, and carbon. It takes 45 of these atoms to make 1 molecule of sugar. Here we're mixing iron filings with salt to illustrate a 3rd kind of material called mixtures. In mixtures, different materials exist side by side and can often be easily separated from one another, as we do here with the help of a magnet. These models show what happens when we mix sugar and water. The molecules exist side by side and do not change. Now let's do the experiment. The sugar dissolves, but neither the sugar molecules nor the water molecules change. They exist side by side in solution. If we permit the water to evaporate, we have the sugar left. No longer in grains, but it is sugar, as we can tell by tasting it. Air is the most common mixture. It contains a number of elements like nitrogen, oxygen, argon, and neon, plus compounds like water vapor and the gas carbon dioxide, to say nothing of dust, smoke, and other impurities. Notice the plus signs? This is how the chemist indicates a mixture, as distinguished from compounds, in which the symbols for the atoms are written together. Most things around you are mixtures. Paint is a mixture of coloring matter and liquid. Any material that contains more than one kind of molecule is a mixture. Wood is one of the most common mixtures. Even the compound water often contains other materials and is actually a mixture. Only pure distilled water is a true compound. So we see that all the materials of our world are made up of various combinations of atoms. These atoms combine into molecules to form three kinds of materials. Materials like aluminum and iron, whose molecules are made up of only one kind of atom, are called elements. Materials whose molecules are made up of more than one kind of atom are called compounds. These include salt and many other common materials like baking soda and, as we have seen, sugar. Materials which contain different molecules existing side by side are called mixtures. All of them are made up of nature's building blocks, the more than 100 different atoms of which the world is made.